So right before I start, Philip, where's Philip? The keynote was great, right? How many of you know that Jackie Chan is opera-trained singer? And he's, a couple people, and he sells like millions of CDs in China. Hardest man in show business. And another thing before I start, I find it ironic that we have JavaScript conference, and the doors here say in, staff only, out, staff only. They are statically typed. Okay. So yeah, my name, everything, you don't care. So every time I code in JavaScript, so I come from computer vision, so C++ all the way. Every time I program in JavaScript, I feel like it's a minefield, and I'm about to break stuff. So why do we do this? Well, the only reason why we really do JavaScript is not because we like it, nobody likes it, but because it's everywhere. You have an impact because you do JavaScript. And if we change just by tiny amount how better we are, or how good we are at JavaScript, we can change everything in the world. My wife probably is not affected by the quality of Java programmers, but she's always affected by the quality of JavaScript programmers who program restaurant website when she tries to make a reservation. So I work at Kensho. Kensho is a financial analytics company, startup. We do lots of stuff, so it's good. And as we develop stuff for our clients, it has to work, and the clients always want new things. That means we have to do stuff quickly. And after a while, we're less than 2 years, we're green kind of field development, but still, there's too much software, right? We have Python backend, we have JavaScript front end, and the code is just becoming mind-boggling. So ultimately, what we want our JavaScript to be is to be as clear when you read it as English, or even better, probably. We always wanted to produce unexpected results. Let me pause. We want to be simple to test, right? Like TDD development is all good, so we want it to be simple. And we really want to reuse stuff. It means if we write something simple, we want to take a couple simple parts, put them together, get more complex part. So I'll skip how we actually got to this, but this is what we actually decided our technology stack or procedure to be. We're going to use functional programming in JavaScript. We think that small, pure functions are easy, and very composable. And we use promises to get rid of callback hell. We use immutable data, and finally, the rest, how we actually put things together, we use reactive programming. And we think of everything, not as individual action where we have to kind of code individually, but as a stream of asynchronous events. And then even server events could be a stream of reactive events. And then there are standard operations. So how we pick them, why, I don't think it's that important, but these are powerful techniques. But when you give it to developer, right, and say, hey, this is what we're going to do, they're like, I have no idea what you're talking about. And it's because we don't arrive to JavaScript, or we're not born into this world saying, I'm a JavaScript developer, right? JavaScript is not species. We all come to JavaScript from somewhere else usually. I come from a C++ world, other people come from Python, or maybe the horror Java. And that means you know different things. And these things are really different from what JavaScript expects you to do. It's not about junior versus senior developer. It's more about breakdown. You can do a lot of things in JavaScript. Some people spend all their time just using jQuery, maybe some CSS. Other people just do exclusively CSS. Sometimes they touch JavaScript code. I'm more here, so I don't touch CSS. We don't use jQuery, so I do other things. There are different types of JavaScript that you can do. So if you want everyone to do good, composable, small, simple JavaScript, that means you have to train everyone and not say, oh, he's junior, he doesn't know all these things. He could be a very experienced developer, but still not use reactive the way we wanted him to be. So in theory, right before you saw the keynote, you think, well, I can take anyone, and in a week, I'll have a hardcore programmer, right? Now we know it's not a week, it's 10,000 hours. But even worse is that you have to go through a whole bunch of steps before you reach it. And once you reach the alignment, you understand it's all in vain. Here are my steps. Usually I give this presentation in at least 40 minutes, maybe an hour, maybe it's a training course. Peter gave me a challenge, feed it in 20 minutes. And I was like, I can do it in 5, but I can't. So you can do all these steps, but we're going to skip a bunch of them. And there are links to more material for each step, but I'm going to skip. But you probably thinking, stop giving me jokes, give me actual code. OK, I apologize for low contrast. Here's my problem. I'm having an array of numbers, 3, 1, 7. I give you a constant, 2. I want you to multiply each number and then print the results. Bang. I've done it, right? This is the typical code that someone who is classical, C++, Java developer, who comes into JavaScript world, they get an array, they declare a constant, although it's not really constant, is it? They take a k variable, they do a for loop, they multiply, and then print right away. This code works, right? But for loop, coming from C++ world, I'll tell you, I hit off by 1 error when I do for loop iteration every month probably, and it's a pain to actually debug. And also, we're both multiplying and we're printing and we do loop iteration in a single problem. So even aside, if we take the JavaScript out of the picture, if you just do code review, you probably will ask someone can you split your logic, right? So this is not JavaScript specific. This is more good programming practice specific. And so you start writing, small functions. Well, you can separate processing. You can separate multiplication. Why not, right? And then my for loop will just process number, and it will give a constant, so kind of pass things. So it's a little bit better, right? But the goal is not to refactor specific, code. The goal is to give a principle. And the first principle I always give to developers at my company is, can you make your code as boring as possible? And so what is boring code? Well, it's the code that doesn't surprise you, and the for loop will always surprise you, right? If you use this in JavaScript, and you assume it's an object with specific context, it will always surprise you. Maybe not today, maybe tomorrow. Sorry. If you use non-local, can you hear me? Yeah. If you use non-local variables like constant inside the function, it will surprise you. No? Okay. So the most boring functions in JavaScript are pure functions. And they're called pure because the output only depends on the inputs. So every time you run it, it produces the same result for the same inputs. This is a classical thing from Haskell or any kind of functional programming language. No surprises. This is what I want to see more and more from the developers. You cannot actually guarantee that a function is pure. It's the same as halting problem. Ooh, computer science. But you can test it, and there's stuff that you can do. Just like boring parents make boring children. A boring function like multiplication can easily produce in JavaScript new boring functions. For example, if I want to multiply 2 numbers, and I always want to multiply by 2, I can create a new function, but just using bind. So we usually use bind to bind the context. But in JavaScript, you can do partial application, left to right, and fill the arguments. And you produce new function that's really very simple to reuse and so on. So now I can do all these little things, and there'll be no surprises. I have not written any piece of code. I just used a language feature. And then people say, well, I don't want to use for loop, so I'll use this ECMAScript 5, because I'm not cool enough to use ECMAScript 6. And so instead of for loop, I'll use for each. So we got rid of for loop. So that's good. But we can go one step further. And we can say, not only you can do a for loop, you can do other operations. For example, there is a map that produces new array. And then there is for each that does something for an array. So already my for loop is nicely separated into steps. The goal when training developers is not to tell them do something, like sit Well, the goal is to give them a cookie. I use almonds in my personal opinion. The goal is to say, you have a problem. Your code is not clear. And then let them kind of arrive at something like this with training. And so really, they will solve a problem and not think about a specific technique. Instead, they'll see the problem and they'll see a solution using language. And then we notice that a lot of our data manipulates, pretty much arrays. And so we used to use map, right, built in, or we could use a library like Lodash or underscore to do the same thing. And then if you use Lodash or underscore, you'll notice that not only you have a map, you can have a whole bunch of extra methods. And all of a sudden, your array processing pipelines become very flexible. Because you're going from using built-in JavaScript functionality to use lots of well-tested methods. Interestingly, if you look at NPM and you look at the most dependent packages, the top two are Lodash and underscore. So even if we don't think of JavaScript as hardcore functional language, people use them a lot. And then you can do things like pipeline, do the same thing that I've done before, but then you can do a lot more. For example, you can iterate over objects the same way as you iterate over arrays. And now the second step that you might take once you start using underscore Lodash is switch the order of arguments. So Lodash puts the array first and then the callback second. If you use a library like Ramda, it puts a callback first and an array. And this is very nice because I can assemble all my steps from functions before I supply the data. So I'm literally writing an algorithm using functional programming and then given an array. Think how testable this is, because my data is the last step that I have to provide. Coming from Java, I always used to write smart objects. I would write something like this, and then I'll write method add, print, multiply. And now, I always operate on arrays, and I use standard methods. So the creator of Algol, Alan Perley, said that it's better to have 100 functions like this that operate on a single data structure, like array, rather than writing 10 custom classes. And I strongly agree. We're going to skip transducers, but now the fun part. We're going to say goodbye. And the first goodbye you have to say is to return values. We're not doing the synchronous programming anymore. Notice in this pipeline, I never get anything back. I always have to do something forward. I don't have to write my intermediate functions. I can just use a point-free programming and skip the intermediate functions. My code is a lot less verbose. And then, if you use immutable data, no more side effects. I cannot accidentally modify my data. It always goes forward. And then the problem, what if my functions are asynchronous? And I'm kind of going to speed up because you can kind of get the feeling of this presentation. Well, promises is a nice solution, except if you want to multiply several numbers, you have to write a lot of boilerplate code. And only real parts are here. If you want to chain asynchronous functions, the promise is not really a good solution. Event emitters are good, because they can handle repeated event over and over. Promise is a kind of single shot thing. You create a promise, it executes, that's it, it's done. You cannot reuse it. With event promises, you can decouple event from a function, right? So you can do stuff like on element, on click. So completely decoupled my browser from my functional pipeline, and we all widely use it. And then you can do things like write your own event emitters and put them into your pipeline. And the exact code doesn't matter, but what matters is I can take any source and I can execute any action. But what I really want to do is, instead of source on, because I don't know what the meaning of on is anymore, is get back to this. So asynchronous programming is a problem. Promises solve it somehow. Event emitters solve it a little bit more. But I really want to do the way that JavaScript intends me to do. Take an array, map, and then execute. And that's what I want to do for my asynchronous programming as well. I want to take any source of event, maybe process it, maybe using synchronous or asynchronous function. Maybe I want a buffer. Right? This is operation that standard arrays don't have to deal with. And then for each value, I want to call another asynchronous event. So again, we're trying to kind of push forward what we can do with standard semantics. We're going to present this problem, or we're going to meet this problem, and then we want to train our developers to look for a solution. So I can skip this, I can skip this, and now we arrive to the reactive programming. Imagine that everything or anything can be a source of asynchronous events. User clicks, server messages. And then you just build a pipeline. Same way as we build a pipeline for synchronous operations on an array, we'll build a pipeline of asynchronous operations on top of sources. So not only we're going to get the same standard operations on each item, like map, filter, we also will have stream control events, like buffer, like zip, like flat map latest. And if you know what flat map latest is, what I'm doing here, you should be earning a lot of money. So think about this example. I'm going to use an excellent library from Microsoft called RxJS. I'm going to create a first source of events, and it's going to be a timer. And it will just generate an event every second. And then I'll have another stream on top of my array. And then I can zip them up. So every second, this will generate an event. This has always a number, which is an event. And then from out of these two streams, I'm going to pick just the number. So I'll get a number every second. I can multiply, and then I can print. So I'm solving kind of the same problem, but now my time events are completely decoupled from my array events. But I'm using standard operations. And if I can do this, well, I can generate an event every time user clicks a button and zip it up with my numbers. So I'll multiply and print a number every time someone clicks on a button. In summary, because I'm almost out of time. If you don't remember anything from a presentation, and I hope you do remember something, write small functions. And then start writing small pure functions that only depend on their inputs and don't depend on global state, on this, or anything. Whenever you write asynchronous code and you have a single event, use a promise. And then if you have multiple async events that you want a pipeline, use reactive programming and use a standard library like Bacon.js, RxJS. So a lot of people ask me after I show them, like, what's the most difficult step here? For me, coming from C or C++, I always want to see a return value. I always want to have a synchronous process. If I use like Perl programming and mutexes, I still have a sync value. JavaScript, you have to abandon that. You always move forward. And the second question was, well, let's say I have a group of developers, right? And how do I actually nudge them towards functional programming or using Lodash or maybe writing small pure functions going all the way to reactive? Well, one thing you cannot do is to say, we just hired you, you don't know anything, now train, right? Because usually people say, I just passed interviews, I'm smart, I've been doing nice things, I don't want to learn things right away. So what we've done instead was we do training for everyone at the company. For example, we can go through a functional programming book all together, both experienced developers and novices. So the new beginners, they don't feel like they're kind of like in school again. we don't feel resentment. Instead, everyone trains together, shares. And the people who already know this will always discover something new and interesting. Score report. So Kensho, our company, we don't use anything object-oriented or prototypical, so we think ES6 classes are abomination. We use a lot of functional. We started using immutable data. We never use lazy evaluation because our problem is not really suitable for lazy. We use promises a lot, events, and we now started using reactive programming. Thank you. And future is bright. You don't have to wait for ES6. You can do everything today. And you can find the slides and the full content there. Thank you very much.